Hello and welcome to this section on generic or custom constraints in PLEXOS. The constraints class is a really powerful and flexible aspect of PLEXOS. Users can write their own expressions to control the operation and behavior of the system using this class. Constraints can be written such that they are enforced only in specified time periods during the simulation. As an example, a constraint to enforce the condition that at least one of the three generators can run at any given point in time can be written as an equation with either an equality or an inequality. The left-hand side generally contains coefficients of the properties to be constrained, while the right-hand side is the constant value or limit of the constraint. The left-hand side and right-hand side are related by what is known as sense, and this can either be an inequality or an equality. An important point to note is that two decision variables cannot be multiplied together, or in other words, the equation must be linear in decision variables. The sense can be input as a less than equal to, an equal to, or greater than equal to, while the right-hand side is a number or the constant term of the equation. The left-hand side is defined by the coefficients of the decision variables in the equation. For example, to control the commitment of units, the coefficient for the units generating decision variable have to be enabled. By default, the coefficients on the left-hand side are summed up in PLEXOS, but a negative sign can also be input on the coefficient to subtract from the expression. In the table, the sum of the unit commitment variables for each of the three gas generators multiplied by their individual coefficient values must be greater than or equal to 1. This enforces the condition that at least one gas generator has to run at any given point during the simulation. The right-hand side of the equation generally has the same units as the properties on the left-hand side. An important point to note is that if the right-hand side day, week, month, or right-hand side year property is used, then the value on the right-hand side will be multiplied by 1000 if a physical quantity such as generation is being constrained. But if the left-hand side has dimensionless quantities, such as the number of units generating in a given interval, then the value on the right-hand side remains as input. Constraints can be written in combination with the date from, date to, time slice, or data file columns. Constraints can be made soft by defining a penalty price, which means any violation of the constraint will be at the penalty price. If the right-hand side of the constraint is tagged with a scenario, then that scenario object must have a membership with the model to be run. Another example of custom constraints is as follows. If the output of a generator has to be limited, then an equation can be written such that the product of the generation coefficient and the generator decision variable is less than the right-hand side input value for all hours. A constraint can also be written to limit the sum of the flows on two lines to be less than a certain value. Considering the 3-bus network used in the exercises thus far, the equation here states that the sum of the flow on the line from node 2 to node 3 and the flow on the line from node 1 to node 3 must be less than 750 megawatts in every simulation interval. In the PLEXOS interface, a constraint to enforce the condition that at least one gas generator must run at any given time would appear as shown. The upper portion of the window here under left-hand side shows the decision variables whose coefficients have been enabled for this equation. The middle shows the sense, which is the equality or inequality to be used in the constraint. and the lower portion shows the constant term or the right-hand side of the equation along with a penalty price. The equation here thus tells PLEXOS that at least one gas generator must be running in each interval, but it is possible to have an interval where none of the gas units are running by paying a penalty of $1,000. The output properties for the constraint class can be enabled in the report object associated with the model to be simulated. Now, we will take a look at an example of writing a custom constraint in the PLEXOS interface. You are welcome to pause the video to try and complete the exercise. The objective of this exercise is to write a constraint so that the sum of the flow on line 1,3 and line 2,3 is less than 750 megawatts in every interval.